Alright guys, welcome back to Wiki Science YouTube channel. In this video we'll be talking about temperature, we'll talk about the thermometer, we'll talk about thermometry, we'll talk about the temperature skills, that is the thermodynamic skill and the thermometric skill, we'll talk about the fundamental interval, we'll as well dive into the aspect of conversion of temperature skills, and we'll also look at the physical properties that varies alongside the temperature. So now let's get started. What is temperature? Temperature is defined as the degree of hotness or coldness of a body. So here it qualifies degree of either hotness of a body or the coldness of a body. Why the device that is used to measure the temperature of a body is called thermometer. The device that is used to measure the temperature of a body is called the thermometer. Now the scientific use of thermometer to measure the temperature of a body is now what we refer to as thermometry. Is what we refer to as thermometry. Now, there's something I want you to note, that there are different types of thermometer, and this thermometer can be used for different bodies depending on the nature of the body. So here we talk about different types of thermometer under the aspect of thermometric substance very much well. But we'll just look at different types of thermometer that which you may have. You can have something like the liquid in glass thermometer, the liquid in glass thermometer. We can have what referred to as the gas thermometer. We can have what referred to as the gas thermometer. We can have what referred to as the resistance thermometer. We can have what referred to as the bimetallic strip thermometer. The bimetallic strip thermometer. We can have what referred to as the thermoelectric thermometer. Thermoelectric thermometer. Now, among all of these thermometers that has been mentioned, you realize that the nature or the functionality of this thermometer is dependent on the thermometric substance which they have inside, or which they operate with. So in this case now, we look at that under the thermometric substance. I'll just pick the liquid in glass thermometer for instance. The liquid in glass thermometer is having a liquid as thermometric substance, and that liquid can either be mercury or alcohol. Well, in case of mercury, you can have something like the clinical thermometer that is used in the hospital to measure the temperature of patients. It can also be used at home in various houses to measure the temperature of body when you have something like pyrexia and the rest of things like that. And temperature of bodies actually varies between 37 degrees Celsius to 41 degrees Celsius. So when you have kind of deviation from this particular temperature, it means that there is actually increase in body temperature. So in this case now, the increase in body temperature can extend to about 42, 43 degrees Celsius, and you can also have it from about 36, 35 degrees Celsius. So in this case now, you can have a range of 35 to 43 degrees Celsius in range. So we talk more about that under thermometric substance. Now let's look at the temperature skills. The thermometer is calibrated in readings. This reading is what referred to as the temperature scale, and the temperature scale is designed based on different particular units. For instance now, you can have what referred to as the Kelvin unit, you can have what referred to as the Celsius, you can have what referred to as the Fahrenheit, you can as well have what referred to as the Rankine, you can as well have what referred to as the Ankin. So these are different the temperature units that which may be applicable. So we now use this particular unit to design what referred to as different type of temperature scales. So let's look at the types of temperature scales. So we have what referred to as the thermodynamic scale, and we have what referred to as thermometric scale. Now, a thermodynamic scale is what is used generally or scientifically for measurement, for temperature measurement, and it is always in Kelvin units. It's always in Kelvin. This particular thermodynamic scale is having just one fixed point. It is having just one fixed point, and that fixed point is the triple point of water. The triple point of water is where the three different states of water coexist with one another. That's the ice, the steam, and the liquid form of water. So here you have the triple point to be the fixed point. So the fixed point here is the triple point. The fixed point is triple point, and the triple point is said to be at that is 273.16 Kelvin. That is the triple point. So here now, if you want to determine the temperature of a body using the thermodynamic scale, you actually have to get the property of that body at the triple point, and you as well get it at that temperature you want to determine. So here now, we now use the formula to determine the temperature to be the property. It can be the length, it can be the height, it can be the volume, it can be the pressure at that particular temperature you want to determine, and you now get the property at the triple point. So I'll just use TR here, but you multiply it by 273.16. It's always in Kelvin. So this is how we determine the temperature of temperature using thermodynamic scale. But when you're using a thermometric scale, you must take note that the thermometric scale can either be in Celsius, it can be in Fahrenheit, it can be in Rankine as well. Also, you must take note that you can as well have the thermometric scale to be in Kelvin. But when it is in Kelvin here, the difference is that when it is in Kelvin here, it will be having two fixed points, not one. It will be having two fixed points, not one. Two fixed points will be included here. It will be having two fixed points. And what are the fixed points? The fixed points are the upper fixed point and the lower fixed point. The upper fixed point is the boiling point of water. So the upper fixed point is the boiling point of water, while the lower fixed point is the ice point. That is where water becomes ice. That is where we refer to as the lower fixed point. Okay, in this aspect now, since we have two fixed points, we can therefore include what we refer to as fundamental interval. What do you mean by fundamental interval? The fundamental interval is the difference between the upper fixed point and the lower fixed point. So when I have the thermometric scale that which you have, for instance, 100 degrees Celsius, and you have here 0 degrees Celsius for Celsius scale now, the difference between 0 and 100 is what? Is still 100. So we have 100 intervals for a Celsius scale. Assuming I'm dealing with what we refer to as Fahrenheit. Fahrenheit is having the upper fixed point to be 212 Fahrenheit and the lower fixed point to be 32 degree Fahrenheit. The difference between 212 and 32 is simply what? 180. So we have 180 intervals to be included here, while we have 100 interval to be included here. So that's where we have that's what we refer to as the fundamental interval. We get to know how we convert from one temperature scale to another. Let's see how we convert from one temperature scale to another. If I want to convert from one temperature scale to another, the method which I'm going to use is that I'm going to consider the upper fixed points of each of the temperature scales, the upper fixed point and the lower fixed point of each of them that which I'm using. For instance now, if I'm using the Kelvin scale as a thermometric scale now, I'll consider the upper fixed point to be the steam point, which is 373 Kelvin, and you have the ice point to be 273 Kelvin. For Celsius scale, you have it to be 100 degrees Celsius, and here you have it to be 0 degrees Celsius. For the Fahrenheit scale, you have it to be 212 Fahrenheit, and here you have it to be 32 Fahrenheit. For the Rankine scale, you have it to be 672 Rankine, and you have here the lower fixed point is said to be 460 Rankine. In as much you remember the upper fixed point and lower fixed point, you can convert from any of this scale to another. For instance, if I want to convert from Kelvin scale to Celsius scale, what I need to know is that, okay, the Kelvin scale, I'll take a temperature on the Kelvin scale. What's the reading on the Kelvin scale will give me equivalently on the degree Celsius. How do you go about this? The difference between that particular reading to the lower fixed point is fractioned, that is K minus 273. K minus 273 means difference. So the difference between the temperature and the lower fixed point is fraction, that is divided by the upper fixed point to the lower fixed point. The upper fixed point here is 373 and the lower fixed point here is 273. particular fraction here is now applicable to all of the temperature scales that we are dealing with. So if I'm dealing with degree Celsius, it will be the temperature scale on the degree Celsius minus the lower fixed point over the upper fixed point minus the lower fixed point. Is applicable here, you have it to be the temperature scale on the Fahrenheit scale minus the lower fixed point over the temperature scale in the upper fixed point minus the lower fixed point. As well as for ranking is also applicable, so I can have R to be R minus 460 over that is 672 minus 460. So here, whichever one that we now want to convert, if I'm converting now from Kelvin to degree Celsius, then I'll have to use the ratio of Kelvin and the degree Celsius together. If I'm converting from Kelvin to degree Celsius, I have to use these two. So here now I have to be 4K minus 273, 373 minus 273 is equal to, that is C minus 0 over 100 minus 0. And here what do you have? K minus 273 over 373 minus 273 will give us 100 is equal to C over 100. So 100 will cancel 100. It means that K minus 273 is equal to C, that is temperature in degree Celsius. So K equals what? C plus 273. So it means that if I'm converting from degree Celsius to Kelvin, I must add 273. So if I'm having like 50 degrees Celsius in Kelvin, 50 degrees Celsius in Kelvin will become 50 plus 273. And 50 plus 273 will give me 323 Kelvin. That is the answer. So if I'm converting like 70 degrees Celsius to Kelvin, 70 degrees Celsius here now becomes 70 plus 273, and 70 plus 273 will simply give us 343 Kelvin. So this is the equivalent of 70 degrees Celsius in a Kelvin scale. But when we talk about the conversion from degrees Celsius to Fahrenheit, let's look at how we convert from degrees Celsius to Fahrenheit. We also use the combination of these two. When we use the combination of these two, then we can as well have this particular conversion where we have C minus 0 over 100 minus 0 is equal to F minus 32 over 212 minus 32. So here I'm taking the combination of these two because I'm converting from degrees Celsius to Fahrenheit. So here I can have C over 100 is equal to F minus 32 over 180. This will cancel this. 2 here will give us 5 and 2 here will give us 9. So we have it that from degrees Celsius now we have it to be, when we cross multiply, 9C is equal to 5 in bracket F minus 32. So here we have the expression to be 9C over 5 is equal to F minus 32. So here we have that if I'm converting from degrees Celsius to Fahrenheit, it will be 9C over 5 plus 32. So my reading in Fahrenheit scale will be 9 times the reading in Celsius scale over 5 plus 32. So for instance now, if I have to convert from 10 degrees Celsius, for instance, if I have 10 degrees Celsius, so the temperature scale is 10 degrees Celsius, and I have to get it in Fahrenheit scale. In Fahrenheit scale, it's going to be, that is Fahrenheit scale now will give me, in a Fahrenheit scale, it's going to give F equals 9 times 10 over 5 plus 32. And 9 times 10 will give us 90 over 5 plus 32. And 90 over 5 will give us, that is 18 plus 32. And that will give us exactly 50 Fahrenheit. It will give us 50 Fahrenheit. So 50 Fahrenheit will be the answer to this particular question. So you can as well take this particular phenomenon anywhere using particular method. When you use this method, it will surely work for you to convert from one temperature scale to another. Okay, let's look at the physical properties that varies with temperature. There are several physical properties that varies with temperature. We can have the length, we can have the height, we can have area, we can have volume, we can have pressure, you can also have resistance. So when you're dealing with any of these particular physical properties, you use the same method which is applied here. It's just for you to define which of the temperature scale you are using. For instance now, if I to use degree Celsius scale, it means that I will only take the degree Celsius scale. Every of these physical properties will I include in the rest. So here now I have degree Celsius, and for this part now I'll use the remaining properties. That is the length, for instance. But this length is the length I'm going to attain when the body is heated to 100 degrees Celsius, and this is the length I'm going to attain when the body is heated to 0 degrees Celsius. So this will be the length that I'm going to get when the body is heated to that particular temperature here. So here we have also here that this will be the volume at 100 degrees Celsius, and this can as well be the volume at 0 degrees Celsius. And at this point you have it to be the volume to attain when the body is heated to this particular what? To this particular temperature. You can as well have what referred to as the pressure here, the pressure at 100 degrees Celsius, and here you have the pressure, and here what you have here will be the pressure at 0 degrees Celsius. So here you apply what you've done earlier to the temperature conversion skills to all of this, and we have it to be C minus 0 over 100 minus 0, as well as you can have L minus L naught over what? You can have it to be L 100 over L naught is equal to, what you have here is V minus V naught over V 100 minus V naught, and here you also have P minus P naught over, that is P 100 minus P naught. You can as well have resistance for this. When you have resistance, for instance now when you have resistance, you can also have resistance. Resistance will be R naught, R, and you have R 100. So you can also have R minus R naught over R 100 minus R naught. So when you use any of this particular property, you can equate it with the temperature scale. In as much you have gotten the temperature at the steam point, you've gotten the property, the effect of that property at the steam point, and you've also gotten the effect of that property at the ice point. You can convert to any of those properties that varies alongside with temperature.